I'm with Zen Magnets, and Bucky Balls are the leading magnet sphere competitor. On September 14th, we started doing the Zen Magnet Challenge, kinda like the Pepsi Challenge except with magnets. It was a little eBay listing that sold both sets and compared them. 2 days later, we get this voicemail from Jake Bronstein, the Bucky Ball guy.
Mr. Q, this is Jake Bronstein from Bucky Balls. You should send me in the next, before the close of business, any reports that you have from a testing agency. This includes Microbac Laboratories, who we use, and who's the other testing? No, but the Intertech or Bureau Veritas. I'm going to want to see where your quality claims come from before I file a lawsuit tomorrow. So those are your options. I'm assessing damages starting right now. We're a $20 million company, and if you think that I'm not serious, if you think that we have an army of salespeople but not an army of lawyers, you're out of your head. So again, my email is jakehimself@gmail. I would send it before the end of the day, or you can cut that noise out. Otherwise, I'm going to talk to you in a very different tone through very different people starting tomorrow. Thank you very much.
Hi, Jake. I'm sorry we couldn't respond within 3 hours with the results from a testing agency. I hope you don't mind if I prove my quality claims right now in front of this camera. I'll also show you how to test for quality yourself, without any measurement equipment, especially since I imagine you guys don't have any. So, the 3 topics of interest as far as quality go are tolerance, coating, and strength. This is an aerospace IP54 micrometer. It's accurate to 1/1000th of a millimeter. We'll measure magnets between these 2 datums, and the thimble clicks when it's reached stable measuring torque. Here's a new set of Bucky Balls, completely sealed, new in box, never opened. Now I'm going to show you how to do science. Bucky Balls are advertised to be 5 millimeters in diameter, but they make no mention of expected deviation. Let's begin measurements. Geometric tolerance affects the repeatability and predictability of use. There are also certain objects that you can't even make with badly tolerant magnets. We'll keep measuring the Bucky Balls on the left of the screen. Meanwhile, these are Zen Magnets. We sell them on zenmagnets.com, and occasionally we do sales on Reddit and Woot. As shown here on film, the measurement process for Zen Magnets will be the same as the measurement process for Bucky Balls. But like I had previously said, you don't have to have a micrometer to test for good geometric tolerance. The measurements will continue on the left, and afterwards we will analyze them. Meanwhile, I will show you the rigid stick test, which requires no additional tools. Take a single file chain and make a loop with about 1/4 of the length, and roll up the chain until the loop is 4 magnets wide. Then slice it into a sheet, which will zip right up into a stick. Finish creating the rigid stick by evening out the ends. This is called the rigid stick test because well-tolerance magnets will always hold rigid and straight. Low-tolerance magnets will create a warped stick that wobbles and sways. Relative magnetic strength is also tested in rigid stick form. Create a rigid stick with even ends and slowly move one end off the edge of a flat surface. Eventually, the beam will fail to support its own weight. You can now compare magnetic strength by counting the number of magnets from the closest failure point. The set of Bucky Ball magnets that we opened on spot was actually about the same strength as Zen Magnets. Measurements for the Bucky Ball magnets are complete. Let's have a look. For the set we measured on spot, the average diameter was 5.009 millimeters, less than 1/5% oversize, a good six-fold improvement from the last set of Bucky Ball magnets that we measured. The standard deviation was 0.014 millimeters, meaning 32% were more than 14 thousandths of a millimeter away from the advertised diameter. This was not an improvement from the set of Bucky Balls we measured for the Zen Magnet Challenge. Only 54% were within tenth of millimeter tolerances. Zen Magnets. Average diameter, 5.001 millimeters. Standard deviation, 5 thousandths of a millimeter. Percent in tenth of millimeter tolerances, 93. The coating difference is so blatant that I'm surprised there's any contention. Left, Zen Magnets. Right, Bucky Balls. I don't really know what else to say about this. Jake! Like you said, your company has grown to be huge in the past 2 years. Good job. But look, this isn't the first time we've gotten bogus threats from you, just for, encroaching on your territory. Yeah, it's gotta stop. Clearly, you are the Goliath in this situation. We are just the humble, insignificant underdog. Do you really feel so threatened by our better magnets that you have to flail your sword at us? Please, Mr. Broinstein, don't hurt us!